The Orbiting Carbon Observatory will make millions of measurements every 2 weeks, dramatically improving the number of measurements we have of the carbon dioxide in the Earth's atmosphere. From that large number of measurements, we can actually start seeing everywhere on Earth where the CO2 is coming from and where it's going to. What OCO will do is give us a much better understanding of the time we have to adapt to such things as climate change caused by the burning of fossil fuels. OCO measurements could give us an indication of how much longer we can burn fossil fuels at the rate that we're burning them now, how much more CO2 we can add to our atmosphere before it does produce climate changes that are unacceptable. But we need the measurements that spacecraft like OCO will make in order to understand the processes controlling the rate of buildup of carbon dioxide in our atmosphere so that we can understand how it will change in the future.
One ton of carbon would be the equivalent of, say, a small convertible sports car. Okay? So imagine a small convertible sports car equivalent of carbon. Now, 8 billion of those are put into the atmosphere every year. That's more than one sports car or 1 ton of carbon being put into the atmosphere for every man, woman, and child living on the Earth today. This plot shows the concentration of atmospheric carbon dioxide in units of parts per million against time. So what you're doing is you're watching the amount of CO2 increase and decrease over time. As the plants photosynthesize and draw carbon dioxide out of the atmosphere, the atmospheric CO2 begins to drop dramatically during the summer. And then as the leaves die and decay away into fall and winter, we reach a local maximum. So the extra carbon dioxide that we are adding to the atmosphere through human activities like the combustion of fossil fuels is what's driving this continually upward.
We're looking at about 233 orbits being achieved every 16 days. So we'll have a global snapshot, basically on the order of 2 times per month. And that'll give us data from which we can go ahead and compare and contrast between months, between seasons, and between annual cycles as well. One of the fundamental goals for the Orbiting Carbon Observatory is to obtain the necessary information and data so that policymakers, not just here in the United States but throughout the world, can make better informed decisions.